Okay, so we're going to talk about perfect square numbers. You guys kind of explored these yesterday on your Desmos activity, and I wanted to go back and make sure we were solid on it. So, like, remember, whatever I type, you can choose to type with me if you have like a split screen. And again, I'm going to be posting these notes in Schoology. So if you need to pull up the Schoology and look at them later, that's absolutely 100% okay. But make sure you get these notes so that way you have them for your files. And just keep, I would say keep a Google Drive folder called math, and you can keep them in there. All right, so let's talk about this. Perfect square numbers. So in the chat, somebody, guys, explain to me, what is it means to be a square? Like, what makes a square a square? What is unique about it?
Like, let's talk about what that means maybe on a
Perfect sides, okay. What else?
Okay.
Has equal sides, right? That's what we're going to be looking at is important, right? So, right angles, good. Okay, so what we're going to be spending time on is the perfect sides and the exact same sized sides. So, like, if, for example, if I had a square with a side length of 4, what would all the sides be? Okay, what would the area of that square be? How about that? 16, good, Chase. Right, so we're going to look at those kind of things, right? So, except instead of looking at squares, like actual shapes, we have numbers that we can kind of think of as squares. We can use these numbers to create like perfect squares if we were building geometric shapes. So the definition of a perfect square number is any number that has a set of what we call duplicate factors. Okay. Somebody tell me in the chat or unmute, what does it mean to be duplicate? What does it mean to be duplicate?
I'm putting some questions there, if you notice in that text box.
Two of the same. Now, does that mean multiple, right? Does that mean exact same or partially the same if I'm duplicating something? And Chase says exact. Yes, that's right. Okay, exact from Melissa. Thank you. Okay, so yeah, so we're going to be looking at numbers that have the exact same duplicate factors. Remember, factors are two numbers that multiply together to make a bigger number, right? We double something. Good, Kyle. So for example, 9 is an example of a perfect square number because I know that 3 is a duplicate factor of it, right? 3 times 3 gives me 9. 100 is a perfect square number because it has a duplicate factor of 10. 10 times 10. 64 is also a duplicate number because 8 times 8. So if I built a square with a dimension of 8 times 8, because all of them are 8, then it would give me an area of 64. So that's kind of what we're going to be looking at today. All right. So when we look at a picture of a square, okay, area is going to represent a perfect square number. Okay, and these numbers are very unique. Only certain numbers can be considered square numbers. Not every number is a square number, right? Because not every number has a duplicate factor, like 8. There's no number that I can multiply that by itself to make 8. I can do 4 times 2, 8 times 1, but I can't do 4 times 4. I can't do 2 times 2. I can't do 8 times 8. Okay, it doesn't have a duplicate factor. Okay, so what is the area of this square? Somebody put it in the chat or put it on mute and tell me, what's the area of this square?
You might not even know if it's wrong if you don't try to answer.
Good. I mean, 49. Okay, 49. So, Yassine, you put 7. That's going to be important, so hold on to it, okay? So 49 is right. Okay, so the area of the square, so what I'm telling you is 49 is a perfect square number because there is a factor that duplicates itself that makes 49, okay? So we talked about exponents a little bit in scientific notation. When you look at an exponent and we have a square like this, okay, we have a square. Good, Kyle. Okay, that's telling us that this is creating a perfect square number.
There are several of you that aren't in and several of you that are not.
That means I'm going to create a perfect square number.
We need to figure out what to do to solve this.
This number is what we call the side length of that square, or what the square root is. So if I give you a number like 100, and say the area of the square is 100, what's the square root of that square? I'm asking, well, what's the side length? What's the duplicate factor? Right, 10. Good, Luna. So that's kind of how square roots and squares look. So let's go backwards. So what if I give you a number in a radical and a square root? Okay, so what is the side length of this square? We know it's 7. Okay, but what is it really in math terms? The side length is the root. Okay, we call this the root, the square root. Okay, so when I'm looking for the square root of a number, I'm asking you, well, what's the side length of the square that it makes? Okay. The number in the radical, okay, the number in the radical, that's actually going to be the area of the square, or we can call it the perfect square number.
The question's asking how much money is collected in dues on the second day. Well, who's paying on the second day? Do we know who's paying on the second day?
So I'm going to make this smaller so you guys see it. So that's the perfect square number, right? And then what we get out, okay, and this is what we call the square root symbol or the radical. So sometimes it's called the radical or square root.
Right. So who didn't pay on the first day? How many people didn't pay on the first day?
So when I'm asking you to take a square root of a number like 49, what I'm asking you is that if I have an area of a square that has 49 units, what's the duplicate factor? What's the side length, right? So we see it's 7, okay? So for our top examples, right? I could put 64 in the radical. And so what would be the length of one of the sides of the squares? Well, what's the duplicate factor of 64? Right. And then it's 8. Okay. All right. So let's go to slide 2. So I want you guys to help me fill in this table. Okay. So if the perfect square number is 1, then I know the unit, the squares, is at 1 by 1 because that's the duplicate factor that makes 1. So we're going to fill in this table. Let's do 4. Let's say that the area of a square is 4. So then what's my duplicate factor? Good, Yassine. 2 times 2, right? Because that's duplicating, and that gives me an area of 4. All right. Well, what's the perfect square number for here?
Total 8 paid.
Somebody besides Yassine. You're doing a great job, Yassine. Somebody else tell me. What would go in this box? Good. 9.
How do I figure out who's
Okay.
left?
What would go in this box?
Am I going to add? Am I going to
Just a 4?
The radical.
What's that, Kyle?
What would you use for the radical on the
Computer?
keyboard?
That I don't know. I don't know the shortcut. That's a good question. I've been trying to figure that out as well. Okay, so yeah, so I would write it as a multiplication problem, right? 4 times 4. Okay, next would be, Landon's already given it to me, 5 times 5. Do we see a pattern developing here?
There we go.
Do we see a pattern? So what would go in this box?
Now we need to multiply.
What goes in this box?
60, 'cause that's how much
1.
49. Okay, good. So what would go in this box? I left this one blank on purpose. So what's the pattern? What comes next? Landon, next? Good. Oh, yeah, good. Good, guys. You're figuring this out, right? This is easy stuff. Good. 64. I'm seeing good stuff on the chat. What's the duplicate factors? Good. 9 times 9. What comes next? What goes in that box? So that's the factors, right? That's the side lengths. What's the area of the square? What's the perfect number?
100.
100. What about this one?
11 times 11.
Good. And then the last box?
141.
144.
Oh, sorry.
That's okay.
104.
144. All right, good. So these guys are numbers that you need to memorize. And I'm not because you have to really, your life will be much easier if you can remember these first 12 perfect numbers. Okay, these are the perfect numbers because these are the only numbers between 1 and the 12 for factors that are perfect squares. Anything that is not this is not a perfect square number in this set of numbers. So like if I had the number 10, it's not on here. Even though 10 is always a nice number, 5 and 2, there's no duplicate factor I can multiply by itself to make 10. Okay, so those are what we call the perfect squares. So what do we call the ones that are not perfect squares? And we can still take square roots of numbers that aren't perfect squares. So what do we call those? Are irrational numbers or imperfect numbers, okay? But we use the term irrational, okay? Or imperfect squares, right? And so we use the term irrational Because when you actually do put this in your calculator, and I'm not telling you not to do this right now because you can do everything I'm going to ask you without a calculator, you would get a really long decimal that never ends, that doesn't have any patterns. Okay. So,
I've been there.
yeah. So real quick, yes or no, does this number represent a perfect square number? Is 38 a perfect square number? So put it in the chat. No, so I'm going to highlight no, right? Because there's no duplicate factor of 38. There's no number I can multiply together to make 38. Okay, so again, this is going to be the, I can still make a square, or I can make a shape that has a 38 area, but it's not going to be a square, right? It's going to be a rectangle. So like 19 times 2, right? That's going to give me 38, but that's a rectangle because those side lengths aren't the same. Right, it's not a perfect, and yeah, it's a rectangle, good. All right, so when we look at the definition of an irrational number, it says an irrational number is a number that has a
So you're dealing with those today.
never-ending
We'll take a look at your agenda.
decimal places that do not have a repeating pattern. So like when we put this in the calculator, you guys would get 6 points, something, 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 and it would never stop. Now the important part there too is remember that it's not a repeating pattern, right? Because if I put in 1/3 in my calculator, it's 0.33333333 with a bar, right? Never ending. But if I asked you what number comes next, you would be able to tell me that it's a 3. So we can express that number as a fraction, so therefore it's rational. Okay. So make sure we're good on that. All right. So we're going to do a little activity now. So how could I estimate the value of this without having to use a calculator? And so we're going to use what we know about perfect square numbers and square roots to help me figure out, well, what is the square root of 38 pretty close to? Okay.
Before you leave,
So here's a table of all your square roots in your perfect square numbers, right? The blue is your numbers. The green is the square root. So if I took the square root of 81, right, what would be my square root of 81? What's my side length?
Robbie, stick around.
9, right? Yeah, because 9 times 9 is 81. So what I want to know, let's see, I'm going to call on somebody. So Chase, you said you're comfortable in talking, so go ahead and unmute. So Chase, if I have a square with an area of 38, between what two numbers, what two areas would 38 fall between?
You would put it between 6 and 7 because 6.
So you're right. So so you're exactly right, but we're jumping a step. Okay, I want to know what areas. So what perfect square numbers is it between?
36 and 49.
Okay, good. So I said it here. Now tell me what you were going to say.
You put it between 36 and 49, or 6, because 38 is really close to 36.
Okay, yeah, good. So I know that if the area of my square is between 36 and 49, but you see on the number line here, those numbers aren't there. The number line is going to have the side lengths or the square roots on it. Okay, so I want to know, oh, well, because I know the square root of 36 is 6. I know the square root of 49 is 7. So I know 38 is somewhere between 6 and 7. And like Chase was saying, he took it a step farther because he's saying, well, I know it's closer to 6 though than it is 7 because 38 is only two values away from 36 and it's 11 values from 49. So I really could actually put it almost right above 6. And it's like 6.14 something. So it is really close to 6. Okay. All right. So on the next slide, I'm going to call on some people and I'm going to ask you guys to help me place these. So these are irrational numbers, right? Because do we all agree that these are irrational? Are any of these perfect square numbers that are in the radicals? No, right? Because there are no duplicate factors of any of those numbers. Okay, some of those are actually prime, right? All right, so let's go with Amelia. Amelia, tell me between what two numbers or what two areas or what two perfect square numbers is 10?
I was just explaining it though, Michael. I was saying that because yeah, no, it's fine. Hear it again. You will not be able to use those.
So if I was going to drop it over here, between what two numbers in the blue would I put it between? 1 and 4, 4 and 9, 9 and 16. Where would I put it? Amelia.
Every time you log in, for what please do right now.
16.
Okay, 9 and 16. Good. Okay, so it goes there. Now, but where would I put it on the number line? So what is the square root of 9? And what is the square root of 16?
Copy that and paste it and make it.
Between what two numbers on the number line am I going to drop this?
Bookmark it now so you have it. But you can always, of course, email here.
Yep, 3 and 4. Perfect. Okay, I'm going to ask you to extend one more, a little bit farther. Am I gonna put this on top of 3 because it's closer to 3, or am I gonna put it a little closer to 4? Which one is it closer
We
to?
get use it again every single day. So if I were you, I would make it a good
Three?
practice.
That's right, because 9 is only 1 point away from 10, right? That's very close to 9. So when I drop it on this number line, I'm gonna put it about right there, okay? Good. All right, let's go with Emily. Tell me about square root of 29. Between what two perfect square numbers does the square root of 29 fall between?
Yeah, and so you're gonna get to use the one in Desmos more than,
25 and 36.
okay?
That's right, so it falls between there, right? So I know it's between those two areas. So where would it fall on the number line then? So what are the roots that it would fall between?
5 and 6.
Okay, am I gonna lay closer to 5 or I'm gonna lay closer to 6?
The activity and then the.
5.
Correct. And this one's almost right in the middle, right? Because it's pretty close to in between, but it is gonna be a little bit closer to 5. Good.
Remember, it'll be
All right, let's go with, Yassine. Talk to me about the square root of 77. Okay, between what two numbers does 77 fall between?
64, 81.
Okay, 64 and 81, perfect. So what two roots am I gonna place it between the number lines? 8 and 9, and is it closer to 8 or is it closer to 9?
It's close to 9.
Correct.
No, wait, 8.
No, 9's right. Well, which one? You tell me.
9.
9, right. So I'm gonna put it about right there. Perfect, thank you. All right, and let's go with the last one. Who's last but not least? Let's go with, all right, Kyle. So Kyle, between what two numbers does the square root of 88 fall? Between what two perfect square numbers does the square root of 88 fall?
81 and 100.
Perfect, okay. And so between what two roots is it gonna fall on the number line?
9 and 10.
Is it closer to 9 or is it closer to 10?
It's closer to 9.
Perfect, great job.
Yay!
All right, so that is, guys, that's what you guys are gonna be doing. That's pretty much what your quiz is gonna be on tomorrow. Okay, now you are not gonna get this table tomorrow, so I suggest that you guys memorize these as best as possible, or just think about, does this number have a duplicate factor, right? That's the main thing. Is there a number I can multiply by itself to give me that number? And if there is, then it is a perfect square number and it lands right on top of a number. If it doesn't, then we gotta figure out, okay, what is it between? And then what is it closer to, all right? All right, so I'm gonna go ahead and stop share. So again, those guys